Alright, back again here guys. We're continuing our review of what we should know so far. Last video we talked about arithmetic and geometric sequences. Just reminded ourselves of the definition and how to find the general term in each case, and in fact the general sequence. This one here, we are looking at series. How do I find an arithmetic or geometric series? What is an arithmetic or geometric series? It is just the sum of the terms up to a particular point in that series. So an arithmetic series is the sum of the terms in an arithmetic sequence. If I really was good, I would go back and edit these and make all of that happen quickly. I don't quite have the time to do that. So that's okay, you're just going to cope. Some of the terms in an arithmetic sequence and a geometric, same idea. Some of the terms in a geometric sequence. And remember we learned about Gauss and his way of adding up the numbers from 1 to 100, getting 5050 faster than anyone, because he realized the shortcut that if you took the first and the last term in that sequence, added them together, it was the same as the second and the second last, third and the third last, etc. And that led us to our rule, didn't it? So if we have a look at what is our rule for the sum of the first n terms in an arithmetic. So I better make a note that this is arithmetic series. On the last video I was very good and used a different coloured pen for these. I'd better do the same thing. I'd love to be consistent. But again, you're going to cope whether I'm consistent or not. Here we go. What is the sum of the first n terms? We use a big capital S for the sum of the first n terms. Well, remember what we did? We took the number of terms and we broke them up into pairs. So we took the number of terms and divided it by 2. And each of those pairs consisted of the first one and the last one. I could just do u1 plus un. If I knew what the nth term was, that would be the easiest way to find it. So it's the number of terms divided by 2 multiplied by the first term plus the last term. We're not always given the last term, are we? So an equivalent expression there, n over 2, the number of terms divided by 2. I've got my first term. What is another way of writing the nth term? We learnt that in the last video, or we revised it in the last video. Well, that would be u1 plus n minus 1 multiplied by the difference, which of course when I simplify this becomes n over 2 2u1 plus n minus 1 times the difference. Of course we talked about how we used to just use a for the first term instead of u1, and you could use t1 instead of n1. So if you want to call it n over 2 2a, where a is the first term, plus n minus 1 times d, no one will be complaining about that either. That is the sum of the terms in an arithmetic series. Geometric series, we left it behind just as you guys were working on a little worksheet that was hopefully going to lead you to this rule. So let's see if you actually got there. Geometric series, so the sum of the first n terms in a geometric series. And what was it for this one? There's actually two different ways we write it. We can take our first term and we can go r to the power of n minus 1 divided by r take 1. Or I can just as conveniently write 1 minus r to the n divided by 1 minus r. Why would we have two different ones? Well, you can see the only difference between the two is that I've multiplied the numerator and denominator by -1 to get from one to the other. What we do know is we are all better at working with nice positive numbers rather than negative numbers. So if the ratio between terms is bigger than 1, if the absolute value of that ratio is larger than 1, I would encourage you to use the first version. So we use this when the absolute value of r is greater than 1. This one here we will use when the absolute value of r is less than 1, because so between -1, +1, we would use that, and that would work nicely. Do you think you need to see how that proof worked? I'm not sure how you went. No one asked about it in the collaboration space, and you do get given that rule in the exam. So I'm going to leave it. Hopefully you guys are going to continue, or you have finished those sheets and it all made sense. If it didn't make sense, ask about it. Put a question in the collaboration space and I will go over that. But that's the rule I need for the sum of the first n terms in a geometric series. The special case, the sum to infinity, the infinite sum of a geometric series. So when is this possible? Again, this is only possible where the magnitude of that ratio is less than 1, isn't it? So this was the example we had where Katie was walking towards the door and we just told her to keep halving her distance between where she started and the door. The sum of all of those distances that she moved was only going to equal the distance between where she started and the door. I think we guessed it was about 6 meters or 7 meters away from the door. In total, walking forever, we had just kept her walking. She'd still be walking today. Distance covered, 7 meters. We wouldn't be able to tell the difference. She could still halve that microscopic distance between where she is and where the door is, at least in theory, but the distance she covers will only ever be 7 meters. How do we work this out? You will notice that as n approaches infinity here, so we want n to be as large as possible, what happens? So we're using the formula on the right because it's when our ratio is less than 1. Let's have a look. I'll actually just step through this a little bit. Whatever the first term is, I have 1 minus r, and instead of n, infinity is not a number, but we're raising it to an infinite power. We're just raising it to the power and continuing to do so as often as possible, over 1 minus r. What happens here in the numerator? 1 minus r to the power of infinity. If I'm taking a fraction, a number between 0 and 1, and I'm continue to raise it to a power, that value is getting smaller and smaller each time. The magnitude of it is approaching 0. It doesn't matter whether I start off with a negative or positive, even though a negative number will alternate between a positive and a negative number as you go along. That the size of the number is getting so small it's approaching 0. So that means, in this case, if the magnitude of my ratio is less than 1, then I can find the sum of the infinite series, the series that just keeps on going forever. And it's a nice and simple rule. It's actually the easiest of all of them. U1 over 1 minus r. I know I'm going to get some questions on that. I hope I do, because I want to go through a few examples and make sure it's really clear. But that should help for now. All right, cheers, guys.